Let xn be a sequence of i.i.d. random variables with common distribution function f. Let fn be the empirical distribution function based on this x1, x2 and so on. Then for each of f of x, fx, for each fixed x belongs to minus infinity to infinity, which of the following statements is are correct? So first of all, like if we consider this fn of x, so fn of x is 1 by n summation I is equals to 1 to n indicator of xi less than or equal to x. So basically this indicator of xi less than or equal to x is Bernoulli with the probability p, so that p is nothing but this f of x. So that means fn of x is nothing but the sample mean of this i.i.d. n i.i.d. Bernoulli f of x random variables. So that means by using the strong law of large numbers, this fn of x is 1 by n summation I is equals to 1 to n indicator xi less than or equal to n. So this tends to almost surely expectation of indicator of xi less than or equal to x. So that is nothing but f of x. So basically this correctly matches with option C. Now if we consider by the central limit theorem, so the central limit theorem says like root n into fn of x minus this f of x converges in distribution to normal f of x into 1 minus of f of x as n tends to infinity. So that means like but in option A it states that it tends to 0 as n tends to infinity, therefore it is wrong. Now option B says n times fn of x minus f of x divided by square root of f of x into 1 minus f of x tends to d z. That means like normal 0 1. But actually this is wrong because square root of n into fn of x minus f of x is tending to this normal 0 1. So had it been square root it would have been correct. So statement B is also wrong. So statement D says variance of fn of x. So variance of fn of x is nothing but f of x into 1 minus of f of x by n. So that means this is variance of fn of x. So n times of variance of fn of x is nothing but f of x into 1 minus of f of x. Now this is not equals to 0 as n tends to infinity. So therefore option D is also false. So therefore option C is the correct answer.